and breach it.
Where the digital hits the physical, we take the red pill, we break the seal. Infallible security, making it real. Bharat Mattaparti on the mic tonight, turning the darkness into light.
Let's move to the code. Decoding the bytes. If the physical world is under siege, the digital foundation is rotting. I want to talk about Inception. In the movie, the architect builds the dream. But if the architect leaves a flaw in the design, the dreamer or an intruder can manipulate the physics of the world. They can fold cities in half. They can turn gravity off. They can reshape the reality of the dream to suit their needs. We build the modern web on a framework called React. It is fast. It is modular. It is beautiful. It powers everything from your banking app to your social media feed. But we built it with a flaw in the physics. Meet React2Shell CVE 2025-55182, a perfect 10.0 on the CVSS scale. For the non-technical audience, the Common Vulnerability Scoring System CVSS goes from 0 to 10. A 10.0 isn't just a bad score, it is a fatality. It is the blue screen of death for your entire enterprise security posture. It affects Next.js and React server components. This isn't some old legacy software from 1995 like COBOL. This is the stuff we built the new internet with. The vulnerability is called Unsafe Deserialization. That's a fancy word for blind trust. Let me explain this mechanism because it is vital you understand how fragile the web really is. Why do we do this? Why do we use serialization? Because it's efficient. We want our apps to be fast. We want seamless data transfer between the client and the server. We traded security for milliseconds of load time. When you send data to an application, let's say you upload a user profile, that data has to be packaged up to travel across the internet. We call this serialization. It turns a complex object into a stream of bytes. When it reaches the server, the application has to unpack it. It has to turn those bytes back into an object it can use. This is deserialization. In a secure world, the application checks the data before it unpacks it. It asks, is this just text? Is this just a number? Is this safe? In a React2Shell world, the application doesn't ask, it trusts. If you hand it a serialized object that contains a command to open a reverse shell instead of a user profile, the application unpacks it and executes the command. It is like handing a bank teller a sealed envelope. The teller is programmed to open the envelope and immediately do whatever is written on the note inside. China Nexus groups, specifically Earth Lamia and Jackpot Panda, weaponized this within hours. They aren't waiting for you to patch. They are scanning the internet right now. They are installing crypto miners. They are harvesting cloud credentials. We built a glass house for our data and we just handed the enemy a sledgehammer. But wait, it gets worse. Because even if your software is secure, even if you patch React, even if your application layer is a fortress, your hardware is compromised. Let us talk about God mode. In video games, God mode means you can't die. You can walk through walls and you can reshape the level. In the data center, God mode is the management plane. CISA just warned us about HPE OneView, CVE 2025-37164, another 10.0. OneView is a software that manages the physical servers. It sits below the operating system. It tells the metal what to do. To understand this, we have to talk about rings of security. Ring 3 is your applications: Chrome, Word, React. Ring 0 is your operating system kernel: Windows, Linux. This is where we think the power lies. But there is a ring -1. This is the firmware, the hypervisor, the management plane. HPE OneView lives in ring -1. Think about your security stack. You have antivirus, you have EDR, endpoint detection and response, you have firewalls. Where do those tools live? They live in ring 0 or ring 3. They live in the operating system. If you hack the website, React, you own the app. If you hack the management plane, OneView, you own the physics of the data center. You can wipe the storage arrays. You can reimage the servers. You can turn off the cooling fans and melt the processors. And here is a nightmare scenario: persistence. If I hack your Windows OS, you can just wipe the hard drive and reinstall Windows. The virus is gone. But if I hack the management plane, I am not on the hard drive. I am on the motherboard. I am in the silicon. You can wipe the hard drive. You can buy a new hard drive. You can reinstall Windows 1,000 times. But the moment you turn that machine back on, I am still there. I am the ghost in the machine's soul. And the scariest part, your fancy EDR tools, they can't see this. They are looking out the window for burglars, while the monster is coming up through the floorboards. This is the Matrix analogy. Neo isn't fighting Agent Smith inside the simulation anymore. Neo has gone to the machine city. He is talking to the source. He is rewriting the code of the Matrix itself. When an attacker exploits HPE OneView, they are at the source. They can delete the logs that would prove they were ever there. They can turn off the defenses with a single command. When you have a 10.0 in the app layer, React, and a 10.0 in the metal layer, HPE, you don't have a security posture. You have a sandwich, and you are the meat. The attackers are eating us from the top down and the bottom up.
This is Bytes, Borders and Breaches. The signal is loud, the lesson